Well, good morning, ladies and gentlemen. I think we may as well kick off. We've had a little bit of delay, seeing that we were running a little long in the keynote this morning. I'd like to introduce ourselves. My name is Tony Goodhew. I'm the product manager for Visual C++ and C#, based in Redmond, Washington. And with me is Pranish Kumar, who is the program manager for ATL Server. Is your microphone on?
I hope so.
Okay, good. So what we would like to talk to you about today is about building web services in ATL Server. How many of you are familiar with ATL Server as a technology already? Okay, so what we're going to do is spend just a little bit of time, very quickly for those of you that are not, to explain what ATL Server is. And then what we're going to do is actually drill down into building web services with ATL Server. Finally, we're going to wrap up and show you how, or talk about how, web services and ATL Server integrate with the .NET platform and the new .NET environment. So firstly, I'd just like to give some explanations of what ATL Server is. ATL Server is part of the native C++ libraries. So it will ship with the ATL libraries, with the MFC libraries. It is targeted for native C++ developers. And it is a new library that we use for creating web applications and web services. How many of you have heard of the Doculabs benchmark that we did? Okay, this is where actual ATL Server comes from. Back with Visual C++ 6.0 and Visual Studio 6, we were actually invited to participate in a benchmark of application servers that was run by a company called Doculabs and by Ziff Davis Labs. Now, the concept behind the actual benchmark was a thing that was called the Nile application, or Nile.com. And as you all know, Nile is a river in Egypt. And surprisingly enough, the benchmark was all about an online bookstore. So you may see some similarities to what they were trying to do there. But we benched that against all of the Java app servers, and we got outstanding results. Both our VB and our C++ implementations were, between 2 to 3 times faster than any of the other implementations. And in fact, the Visual C++ implementation had a 33 times price performance gain over the nearest Java running on Solaris implementation. But to do that, it actually took us about 2.5 to 3 weeks of dev time, where we sent people from the Redmond dev team down to San Francisco to implement it. We spent all this time hand coding C++ to actually do that. And realistically, that's not something that we can expect our customers to be able to do, is to either have that quality of dev or to be working on sort of projects that really require them to go and do that. So when we came back after winning that, we sat down and we said, how can we take the knowledge we gained from that benchmark and make it available to customers? And that's where ATL Server was born from. How can we create a generic way that allows you as developers to actually go and build the most high-performance web applications? So we looked at utilizing the concepts of ATL, utilizing templates to give us flexibility and performance. As you're probably aware, ATL is or the Active Template Library, is a very lightweight library that we have for building COM components. On average, ATL adds only about 35K of code size to a COM component over hand implementing that component yourself. And we decided that we're going to build this on top of ISAPI exactly the same way we had in the actual Nile benchmark itself. So what type of person should be looking to utilize ATL Server? Well, it's people who want to build web applications. It's people who want to make web services, and to do so either by integrating with existing C++ code, either through the desire to make the absolute fastest implementations, for that control that you would expect to get, for the flexibility. One of the great things about the native C++ language is that it's got this incredible, great control, flexibility, and power. One of the questions that will come up, and I'm guaranteed that probably some of you are thinking about it right now, is, when should I use ATL Server over ASP+, or as it's actually just been renamed, ASP.NET? So when you start thinking about that, you really have to start thinking about the types both of application that you're actually building and the type of challenge you have and the type of developers you have. If you want to use ATL Server, your devs have to be C++ developers. ASP.NET can be developed from inside any language on the .NET platform. You need to start thinking about productivity of those developers. You need to start thinking about what the real performance goals are. Often, most of your companies will find that the performance requirements, the performance metrics they have for their applications really allow them to benefit from the productivity of an an ASP.NET application. However, a percentage of customers really benefit from ATL Server. We were down talking to Hotmail, and they actually have gone and implemented by themselves an architecture that was somewhat similar to what we've done in ATL Server. Now, those guys run 3,600 web servers for their 65 million customers. And if you can give an app that has 5 to 10 to 15 to 20% performance improvement over 3,600 servers, you could save anywhere up to 720 machines, and these are not light-end machines. You can look at having an enormous cost benefit by going to ATL Server. So ATL Server is really targeted with performance and control as the #1 design point. So again, who should be using that as native developers? People who are currently doing ISAPI development today. If you've got ISAPI extensions, if you've got ISAPI DLLs, you should be looking at ATL Server. If you've got classes you wish to reuse, the great thing about ATL Server is we will ship you the source with the actual Visual C++ product. So there is no black box. It's not like you call some random DLL and it actually goes and generates stuff for you. Yeah?
Are you using ATL Server to build the ISAPI extension for ASP.NET?
I don't believe they are at the moment. I've heard, though, that they're using parts of ATL Server to do some of their work.
There is great internal rivalry between the ASP.NET team and ATL Server. Primarily that's because currently under perf we're kicking some serious coit. They complain that it's because we run in process and they run out of process. And we say that for people that are building ATL Server apps, if you're running out of process, you're insane. So it's interesting. But as I was saying, there really is no black box. We'll ship you all the bits. So when you actually build these ATL Server applications, in fact, let me go to my next slide. What you will actually build, and Pranish will show you this. I believe you run the wizard in the demo, so you show building this. Basically, what you build initially is you build the ISAPI DLL and the application DLL. So if you don't, you can actually go in and in each of your projects have a specific ISAPI extension DLL associated with that project. So how does the actual sort of architecture work from a high level? Well, what happens is the client comes in and makes an HTTP request for an actual file. Now that HTTP request is associated with a particular ISAPI DLL. So in general, what we have is we have what we call our SRF files. And you can think of those as HTML stencils, and Pranish will talk a bit more about these. Those HTML files, those .srf files, are associated with the ISAPI DLL. So when the HTTP request comes in and says, go get me the .srf file, we'll go get the .srf file, trigger the ISAPI DLL, and then hand the SRF file off to the ISAPI DLL. Now, the ISAPI DLL at that point can work out which application DLL. Now, the application DLL is where you put most of your app logic will exist in that app DLL. You can have more than one app DLL in an actual application. And you can split those up. You can have more than one handler, and you can control all of that in the SRF file. But effectively, we will then go and parse the SRF file, call the application DLL, and go and handle actual tags that exist in the SRF file. And then we go and return that information back to the ISAPI DLL, which then gets returned back to IIS and back to the client. Now, one of the reasons we took this two-level approach is that we don't need to lock the application DLLs in memory in process with the server. So what that means is that you can actually upgrade your application DLL as you go along through the process of implementation and deployment. So what will happen is, you can add a new version of the app DLL, and we will actually go and detect that you have updated the app DLL, and we will handle new requests going to the new app DLL, and all the existing requests being held out of the existing DLL until their service cycle is done, and then we pass over to the new DLL. So this makes it a great way for you to not only build these incredibly high performance websites, but also maintain the deployment, maintain the ease of manageability. So with that, what I'd like to do is to hand over to Pranish, who will actually go into why specifically we chose ISAPI and talk and do more of the drill down into actual web services themselves. We'd really like the session to be a bit interactive. So if you have questions as we go on, feel free to ask them. There will be some time for questions at the end as well. Yeah.
What does the HTTP request look like on the client? Is that just a request of a full page?
Yeah, you're just doing an HTTP GET.
Well,
saying. Oh, the question is, what does the HTTP request look on the client? So if you were in IE, you would type in IE, HTTP, www.servername.com/pagename.srf. And IE just does an HTTP GET and says, get me this page. Because all it's thinking it's getting is just HTML. So at IIS, because we've asked for the .srf extension, we can link it to the ISAPI DLL and then actually go and parse the page and hand it over. What we actually stream back to the client is just pure HTML. So as far as the actual interface is concerned, if it's an HTML 3.2 capable browser, it's capable of getting the, to look at an SRF file. It's not like there's any client-side work actually being done.
Would there be a way to do some kind of function call, multiple function calls on a single page?
Right, yes there is, and we'll show that when we actually see what the stencil file looks like. And you can comment on how you can have the links from individual entries in the stencil file going to individual handlers for each of the functions and that.
Yeah, we'll be going into that shortly, actually.
Okay, well with that I will hand over to Pranish.
Okay, thank you very much. So, for those of you who are not familiar with ISAPI, it's basically just a C-style API, which is in Windows. We came up with ISAPI and IIS because process creation under WinNT is not very good, so CGI is really, really bad. So with IIS, we have something that competes with any of the Unix platforms. Most servers installed on a Win2K system will actually be faster if they're well written in IIS than a CGI competitor. So there's two types of ISAPI extensions. There's filters, two types of ISAPI DLLs, I should say, filters and extensions. So ATL server was designed to work with extensions. It's for people building extensions. This is another reason why we don't see ourselves so much as competing with that ASP Plus target market. I mean, usually we recommend ATL server to people who are going to have to build an ISAPI extension. And if you look out in the marketplace, there's a lot of large companies building websites like Hotmail or Dell that are forced to use ISAPI extensions for the control and flexibility. So ASP traditionally is our solution for building websites. And it's a very heavy scripting-based language. Is there a question, sorry, at the back? Or someone just stretching? It's a very heavy scripting-based language. So it adds a lot into your code. And the point of ATL server, I think, as Tony mentioned, was we want to keep things lightweight, keep everything under control. So like you said with the DocuLabs test, and I'll go a bit more into this now, was that it was this test that was put together by a team of developers, and they realized it was quite hard to write. You're talking about writing an ISAPI extension, which is what we tell our customers to do for high-performance web applications. And it really isn't an easy task. It took them a lot of time. They're all experienced programmers. So we used the Nile to run our performance tests. We have it written by our QA team, and it took them less than 1 or 2 weeks to write up the same implementation using ATL server. And we're within 10% of the original Nile performance, and we try and keep it about there. So performance was one of the key design criteria because of the DocuLabs testing. Because of the big importance of performance, we provide Perfmon counter support in Win2K, so you can monitor your site's performance. And there again, you see, we were within 8% before we turned on caching. And caching actually helps us get even closer. And there's a link to the DocuLabs article on http://manta. Not all of you may have access to this. I think if you go to PC Week, they have a link to the article somewhere in their archives. So let's have a look at actually how ATL server works. And we'll start with handling requests and the SRF file, the stencil server response file. So the idea behind creating the server response file was that we wanted a file which completely separated your dynamic and static HTML content. And basically so you could have your HTML designer sit down and lay out the page for you, and you have your programmers sit down and put in the actual dynamic, the code, the functionality. And there's no need for the programmer to go play with the HTML file, and there's no need for the designer to go into the code and change outputs. And that was really the goal behind the whole system. We use a fast pass once technique, so we only scan through the SRF file one time. And we provide some support for various things, and we'll actually cover that. What I'll do now is actually take you through the ATL server wizard, and then I'll show you some of the features of the SRF file. Okay. So here if we go, I'm going to try and create a poster shop. I've had a lot of trouble on the laptop getting this to run, so we'll see how it goes. So I'll take you through the various settings in the wizard. In the project settings, you see we let you generate your application and ISAPI DLL. So the ISAPI DLL we give you is not a binary. It's generated as source code in your, like wizard generated source code like anything else. You can go and modify it as you want. We've tried to give you as much control as possible over everything. I'm actually going to uncheck the deployment support because it's a bit hit and miss, so we won't take a chance with it at the moment. We also give the option of generating combined DLL. If you don't want to separate your ISAPI DLL from your application DLL, you can generate them both together. There is a cost with that in that application DLLs can be copied onto your server on the fly. You don't have to reset your server to replace application DLLs. So we encourage people to put logic in the application DLLs that they think might change fairly often so that they don't have to restart their server. Obviously, if you combine into one DLL, you can't do that because as soon as you replace the ISAPI DLL, you do have to do an IIS reset. But then on that same token, the people I talked with on the IIS team are telling me that with Whistler, I think, if they get IIS 6 in there, the IIS reset now is so fast that often people don't even realize the server's reset. So that's pretty good news too. Under the server options, we have basically, these are options which affect your ISAPI file. These are things which will be shared across all your applications. So we recommend you put things like your cross-application caching, your performance monitoring support has to go in there. For the time being, we'll just try using the data source cache and the performance monitoring support. You also see we offer session services. Session services are basically just a session state. We offer a database-backed session state so that people can have cross-machine shared sessions. So you can share your one session across multiple machines on a web farm, for example. Or you could have memory back session state if you just had the one machine you were trying to share session with. Under application options, these are things which affect your application DLL. The validation support I will cover a little bit more soon. Stencil processing supports, the stencils are basically the SRF files. So it's support for processing those. You can also create a web, sorry, yes. Sorry, what was the question? I don't believe it does at the moment. No, we have been asked. What was the question? Oh, sorry. The question was the session state services work with the application center load balancing. And at the moment, I don't believe it does. It may before we ship. We are looking into that at the moment. So you can create a web service on project startup, or you can do so later on. So we won't use it for the moment. We also provide locale and code page support for international web pages. On the last page here, I cover the developer support options. These are just some of the more general options. You'll notice attributed code and the custom assert and trace handling support. I'll probably talk about some of the assert and trace handling support later on. We have some really nice features with Visual Studio 7 and the new debugger, and basically error messages that IIS usually tries to hide from you, you can actually get access to with the new debugger, which is really handy for debugging servers. Attributed code, for those of you who don't realize, and I'll talk a bit more about these later on, it's basically just a new design philosophy in Visual C++. The idea is you can separate your implementation details from your actual logic. So we will look at attributes later on, but for the time being we'll turn them off. We'll just look at a plain C++ implementation. Whenever you have attributes, you don't have to use them, so you can use just the C++ version. So let's create the project. And you'll notice we have the two projects created there. And we'll start, what I'll actually do is start building the project, because that'll probably take a while. And then we'll start by looking at SRF source code. And I'll increase the font for you. Hopefully I'll be able to increase the font for you. That should be clear. I hope everyone can read that. So this is what an SRF file looks like. And you'll see, first off, it looks very similar to an HTML file with a few minor differences. The first one you probably notice is this handler tag here. So you notice something funny about it already, because it's surrounded by the double braces. So double braces is what ATL server team decided to use to represent tags in our files. There's two main reasons why we chose the double brace syntax. The first is that it doesn't show up because it doesn't show up in HTML editors. So an HTML editor like FrontPage will not try and do anything with a double brace tag. So that helps separate, for someone designing the page, from how the dynamic content from the static content. So you can work with static content in something like FrontPage, and when you insert a dynamic tag, FrontPage won't try and do anything funny with it, and all the other editors we could find wouldn't try and do anything with it. What's really nice about the double braces is that you can use them within HTML tags. So you can put one of these anywhere, basically, in your HTML document, which lets you do a lot of nice things very easily, like dynamic fonts and colors, by putting these in HTML tags. And we'll see some of that in a moment. So what a lot of you are probably wondering is, what is this handler thing, if you're not quite sure? A handler is basically just a system we provide in ATL server. Basically, you have a request handler in your code. The The request handler is just a class. There's a handler map to expose that class. The handler map will basically map between a text string and a class name. So you'll see a handler map which will link a text string to the class name, and then you will see in that class how it handles a particular request. So here in the handler tag, we give it the DLL that will be handling our request. So in this case, posters.dll. And in this case, the text string which will map to our class is default. And I'll show you that in a few minutes. So the rest is basically just HTML, except for this one tag here, the hello tag. The hello tag will basically map to a method in your class. So the handler tag, and you can have multiple handlers for an SRF file, will map you to the class, and then this will map to an actual method in that class. And there's a replacement map which does that method, and we'll see that as well shortly. So let's actually have a look at what this will do. I'm actually going to try and copy all the files to an external machine back in Redmond, so you'll actually hopefully see this work as it would in a real situation where you're connecting over the internet. So there's actually, when the deployment project is working, it'll do this all for you, which is nice. So I copy my files up. The only other thing I'll have to do is go to the Internet Services Manager. Deployment will also do this for you when you when it's fully working. At the moment, it works sometimes, not in all builds, and not always correctly. So that's why I'm trying to avoid using it. So it's also a good chance to see how you set up a web server for those of you not familiar. Basically, I can show you how we map. We map the DLL and the SRF file. So I'll actually edit these mappings. So, oh, well, they're already mapping to our posters.isapi.dll, so we should be okay. So that means whenever a SRF or DLL request comes in, it'll map to this posters.isapi.dll. So let's actually try and connect, and hopefully it'll actually work. And there you go. So this is a test hello world, and if I move this down here, you can see this is a test. It's just plain HTML, and the hello brace has been replaced by hello world. Now, because this is all server-side, if I look at the source code, it's simply the HTML source code. So there's nothing else going down to the browser. It's just a plain HTML request. Yes?
What happens if you request a DLL instead of the SRF file?
Okay, so the question was, what happens if you request a DLL instead of the SRF file? A DLL by itself will not do anything, but what you can do, and this may or may not work currently, like the way I'm going to do it, is you should be able to no, the wizard by default won't set up that mapping. What you can do is actually use a query parameter like that and set the handler to the method, and then we'll actually call that method. It's more useful for doing web services, linking your DLL to the SRF file, because your web service will actually be a DLL. Let me switch back to the slides for a second, and we'll have a look at handlers. Before that, I'll just talk to you a little bit now, before we go into the code for the handler. You can have, like I said, multiple handlers in a single application DLL. The syntax, like you saw, is you basically just keep doing that. There's a slight difference for additional ones. We changed that syntax slightly. You have to have one handler for any SRF file. Obviously, it needs to know which application is going to handle the request, but you can have more than one, which is very nice. We will see attributes later on. They do help simplify the code. They do help separate the implementation from the logic. What they do really nicely is that when you're working in the code and using attributes, you can sort of put things where you think of them. So as opposed to having to scroll up to a map to find where you're mapping something to something else, you can actually put it on the method which is going to be mapped. So it does some very nice things like that for you. So with handlers, you can simply think of your job as creating the methods, which will be called from the web page. ATL server provides all that glue to hold that model together. So you write a method, you write the tag, it just works. The nice thing that ATL server also does is we provide extra functionality, such as caching and thread pooling, but also things like validate and exchange. So things which are traditionally quite tricky, like when you have to manually validate and exchange off the ECB, like query parameters or form parameters, we provide helper functions to help you do those. So you can easily validate that a form data is correct and then exchange that information into variables in your application. So let's actually go back to the code now. Handler looks like. So we'll start with the handler map. My explanation before was probably not 100% clear, so it's nice to just have a look at the actual handler map. So you can see all it is it's mapping the default string to the cPosters handler class. So it's a very, very simple posting. Now this is one of the things you don't need when you use attributes. You actually put it on the class. So if we go to the cPosters handler class, you'll see it inherits from cRequestHandlerT. All ATL server request handlers will inherit from cRequestHandlerT. You'll probably also notice as we go along, by the way, that ATL server is a class library, not a template library. So those of you who are afraid of using templates for whatever reason shouldn't have anything to fear. It is built on top of ATL, which is why we took the ATL name, and it's also been designed with the same ideas as ATL, in that it's fast, it's flexible, it's lightweight, but it isn't actually a template library. So let's have a look at the replacement map as well. You can see here the replacement map maps the hello string, or the hello tag as we had, to an onHello method. And if I scroll down, you can see that the onHello method is right here, and all it does is output that string we saw previously. So the hello world string. What we also have here is the validate and exchange function. This is a great place to put all your initialization code. So this is called before any page is rendered. So it's a great place for processing form data or connecting to a database or something like that. Okay, so let's go back to the SRF file for a moment and let's try and change the functionality. And really I should have this on a drag and drop system, but I was having a lot of trouble getting this to work, so we'll see how it goes. So I'll just copy in the new SRF file that we'll work with. You can see our handler is the same. We've put it in comments this time. That helps actually remove it when you're looking at it in an HTML editor. The handler tag is the only one you can do that with. And it's nice because it doesn't really represent dynamic content. It's just representing which file will handle your requests. So if you look, I just have a very simple HTML file. It's just a table. You'll have a poster name, a poster description, and a poster image. You'll now see some of our flow control, while get next poster. So we only provide an if, an else, and a while statement in ATL server flow control. There's two reasons for doing this. Firstly, it makes it very lightweight. You can do almost everything you need to do with if, while, and else. And it is an extensible model. So if you do need your own constructs, you can add them at will. The second reason we did it, and one of the main reasons, is we went and looked at a lot of the major sites on the internet, such as eBay and Hotmail, and we found that they only really use those three constructs in the majority of their flow control. And that really means it's just extra overhead, having a whole scripting language, when most people are only using if, else, and while. So they're the only three we provide. Again, it's extensible, so if you really need a for statement or something like that, it is possible to do. So we have three more tags here: get poster name, get poster description, should be fairly obvious, The nice one here is probably the image source equals get poster image URL. This is an example of how you can use the double braces and just put them within an HTML tag. Because ATL server doesn't try and pass the HTML, it'll just output this stream, and when it hits the double braces, it'll replace it with whatever your method replaces it with. All the if, else, and while statements need end statements on them, so it knows which part to continually recreate. So let's look at the code that actually will do that work for us. So the first thing we do really is just create the extra replacement methods. So I won't type these all in by hand in case anyone's afraid they're going to be sitting here for a while. But I'll just give you an example of how it works. We'll start with get poster name. And you just map that to on get poster name. For example, that's just, you can call it whatever you like. We just like using the on syntax. So now all you have to do is implement that method. There's two things we should probably know. That firstly, if you return HTTP success, so it's just the HTTP codes, that obviously indicates a success. So for something like a while loop or an if statement, that'll say keep going through the loop, or take this if statement. The other common return is return HTTPS false. And that says that this loop has failed or this construct has failed, so stop doing it. We also have all the other ones like HTTP fail or something like that, and that'll actually just kill the rendering process. So instead of watching me type in all this code, let's actually go to my very messy clipboard and copy in So all I've done is copy in function bodies for all those tags we saw previously on get next poster, on get poster name, on get poster description, and on get poster image URL. So this is the part where I've been having trouble, so hopefully things will work out this time. So to get all this information, typically you try to connect to a database. So usually I would have a SQL database set up and it would all work without any problems. But this time I'm actually going to try with an Access database, and it hasn't been as friendly as the SQL databases usually are. So we just use the ATL OLADB consumer wizard to connect to the database. We select our data source. Put in the. So this is actually on a remote machine again. And before I try doing that, I should probably actually copy the database up. So that'll just take a second to go up, and now we should be able to connect to the database if all is well. Okay. So now we connect to the poster list table. It's just a list of posters, and we finish that connection off. So here you see an example of attributes. They're really great for database connections, actually. So you can see we just declare our database source and our SQL command. We put it on top of a class. And basically everything coming back from this SQL command, the description, ID, image URL, title, will just be mapped to variables in that class. So just member variables of the class. So let's include that in our code. and we will instantiate a member variable of the type of that class. Let's see poster list. Okay, so now we should just be able to copy in the function. So for an example of what we're going to do, actually I'll copy it in and then build it, because otherwise we'll be waiting forever. So I'll just replace these functions. I will talk you through what's actually going on. I'll need to, so again, this is an excellent place to open a database connection in the validate and exchange, sorry, that was. Hopefully this will build without errors. And hopefully while it builds, I can move around through the code. Okay, so we start with onGetNextPoster. So this was the construct we used in our while loop, while getNextPoster. So basically, as long as we can move to the next entry in the database, this will return HTTP success, and as soon as we fail, it returns HTTPS false. So every time it connects to the next member in the database, we will create this HTML, this tr to tr, td, get poster name, description. We'll fill all that out every time. So these are very, very simple functions, as you can see. All we're doing is using the mHTTP response, and we're just sending back, for example, the title, in this case, the description, in this case. They're all just one-line methods. So it actually built, okay. Let's try copying that up. We'll overwrite the old file, and we'll also copy up the DLL. And just to be safe, I'll copy up the ISAPI as well. Okay, so whenever you change the ISAPI file, it's good to do an IIS reset. And I'll do it even though that's no guarantee that anything will work over the system, but we'll see how it goes. So hopefully when I refresh this page, it will connect to the database and show the database information, but I haven't been having much luck with it today. So again, it doesn't look like it's going to connect. I'm pretty sure it's the Access database that's causing the problem. I do have a local version though. Should have a local version. Oh. And there we go. So that's a local version of the same project that I created earlier, just for such an occasion. And as you can see, we're just listing the poster name, poster description, and poster image. If we view the source, you can see it's exactly what we had in the code, except where we had the tags that have been replaced by information from the database. And that's the while loop has created the 3 rows in the table instead of just the 1. Okay, so let's go back to the slides and look at some of the other features of ATL Server. One of the key other features we have in ATL Server is our debugger support. Yes, sorry. The HTTP requests? form data and stuff, yes, you can pass all that information around to your application DLLs. For anyone who didn't hear the question, it was whether you could pass like form data and HTTP requests around to your application DLLs, and the answer is yes, you can. We also have static parameters there as well, in case anyone was interested in parameter support in the SRF file. I was supposed to cover that. I think I missed it. So let's look at the debugger support. It's traditionally one of the big problems with creating web applications with IIS and ISAPI is that it's very hard to debug the application. So with ATL Server, this is much easier. With the new debugger, you now have F5 debugging support. So when you build and deploy your application, when those systems are working, you hit F5 and it will actually start your web page and attach the debugger, and you'll be able to debug your project. So if you're running in process, the application to attach to is inetinfo.exe, but the debugger will do that for you automatically. So that's quite nice. The new debugger has a couple of other features which are great for creating web services. The new improved Unicode support is very handy. So when you're creating international pages using Unicode, they now come up. Previously there were some problems opening them in certain watch windows and things like that. That's no longer the case. There's now multi-process debugging, which is great when we talk about web services in a few minutes. You'll see that you can debug like a client and a server from the same IDE at the same time. They can be on remote systems and things like that. It's a really great feature to have. And the H results being automatically shown in the watch window is something the debugger team likes me to tell everyone, even though it's probably helpful in all applications, not just the web applications. So let's actually have a look at web services, because ATL Server is also where you create your web services. So why did we want to do native web services? Well, for a native developer hoping to fit in with the .NET architecture, it was realized that there was nothing really there to support them. So they came to the libraries team and asked us to help people create web services so they can join .NET. And the reason we decided to put it in ATL Server is very simple. The ATL Server request architecture is very well suited to handling web service requests. What you have is exactly the same system you had before. A request comes in, HTTP request comes into the server, IIS dispatches it to the ISAPI, ISAPI dispatches to the application DLL, application handles the request with SRF files. You have exactly that architecture, except now the request handler has to be able to understand SOAP. And for those of you who don't know what SOAP is, I'll cover it in a minute. It's the simple object access protocol that helps make web services work. So the other beautiful thing about putting this in ATL Server is that it allows you to expose your website as a web service. So what you could have is that poster list we saw earlier. You could expose that as a web service. So another shop that wants to start selling posters and link to your site can connect through that web service and display your poster list, and it looks to the customers if they're buying from that shop. It works well with the ATL COM system, so if you want COM components to call into web services, we provide functionality to help you do that, so you can use old applications and upgrade them to start working with web services. And again, everything in ATL Server is very flexible. Everything we provide you can use or not use. You only pay for anything you decide to use. You can change it. It's all given to you as source code, like all the rest of the libraries are. So really, like a lot of people tend to just use certain features of ATL Server and not the whole pie. And that's really something we like to impress upon people, that you don't have to use everything. You can use whatever you like. If you don't like our stencil processor, don't use it. What does often happen is people start off using something like our thread pooling or caching, and then they find that, hey, I do need a stencil processor, and your one's extensible and it's lightweight, it does everything I need, and they do end up going to using it and modifying it for their own use. So on the server side, with web services, we use attributes to mark our SOAP methods and request handlers as SOAP methods and as web service request handlers. We'll look at some of the code shortly for that. With web service, it's definitely much easier to use attributes than to write the code by hand. And definitely it's one of the key reasons for using attributes in Visual C++. So basically, we'll have a SOAP handler, which we'll look at soon, which will a SOAP method. A SOAP method will be able to input and output SOAP, and a request handler will be able to handle web service requests. And we'll look at that shortly. In fact, we'll have a look at it now. So let's actually create a web service solution. We'll close down our poster shop. And I'll just call it web service. Maybe I won't call it web service. So again, we generate exactly the same code. It's application DLL ISAPI extension based. Again, we'll skip over the deployment support. Now this time we will create this web service. So we lose some of the options. We can still have caching. We can still have all the previous options. We lose the application. Validation support and stencil processing don't make sense in terms of creating a web service. So it has to be attributed because, like I said, the normal code is very, very messy. You can write the normal code if you like. So let's just have a look at exactly what a web service looks like. So we'll start by looking actually at the inline interface. So this is new to Visual Studio 7 as well. It works with COM as well as web services. And basically with this new __ interface command, we've allowed you to create interfaces in your actual source code. So this is just a normal header file with the rest of the source code, and your interface is defined right there. The UUID, that's an attribute on top of the interface. And you can see here we've got an interface. It's exactly like idle. It's basically inline idle. You've got your H result, hello world. It takes a string input and returns a pointer to a string output. It works exactly the same for COM interfaces now. You can use this inline idle to define those. And it gives you a lot of advantages. It saves you having to rewrite code in a lot of places. It saves you having to register various things. It saves you, if you do change a code and it doesn't match somewhere else, now because it's all in line, the compiler can detect that for you and it'll warn you that things don't match up. So let's take a look at our request handler. So you can see the class C demo service, which inherits from our interface, has the request handler attribute on it. The request handler attribute basically is the same as is used for web applications. It just means that this class will handle requests. There are two extra things on this. Well, we saw the name equals default before. We haven't seen this one. SDL equals demo service SDL. We will look at SDL and SCL shortly. It basically stands for Service Description Language. And this actually will create a web address where you can get the service description language for this web service. The service description language is a SOAP XML description of what your web service is. So it explains in SOAP and XML what your inputs are, what your outputs are. It's there so that anyone looking at that can understand your web service and connect to it. We also have SOAP handler because this will be handling SOAP requests being a web service. It just gives some information to the compiler about what information to inject in terms of SOAP handling. If we scroll into our method, we see the SOAP method here is hello world. The SOAP method attribute means that it'll be able to handle SOAP requests. So like I said before, the inputs and outputs will be converted to SOAP. The beautiful thing about ATL server is it does all this for you. You don't have to worry about doing all this sort of muckery with the code. So let's actually deploy this, seeing we seem to be having so much luck today. So if I go to the demo service, you'll notice, I don't know if you can read this, it generated a disco file. We'll also cover those soon. A disco is discovery file. which is used for discovering web services with Visual Studio 7. So let's delete our old poster example. So that's understandable. And we'll copy up the new files. So as you can see, it's the same as before, except this time we only have a DLL. There's no SRF file. And this will actually let me show you how the DLL system works when you type in a DLL on your web browser. So the first thing I'll actually have to do is just reconfigure IIS to handle handoff requests to the correct ISAPI DLL. So we'll remove the old mappings and add the new ones. Again, this will be handled by deployment when deployment is working. So it's posters / demo service isapi.dll. And the more important one this time is the DLL handler. So we'll do an IIS reset to make sure that's refreshed. And hopefully now, I'll start up a Internet Explorer. I should be able to connect to that web service and have a look at that. So what we'll actually look at is, this time it should work, is if we go back to our code and look at the SDL generator that I was talking about previously. We should actually be able to connect to this and view the SDL for the web service, which again is the service description language. And there we have it. So this is what the SOAP XML service description language looks like. As you can see, it's a demo service. You can see that it covers the hello world, the input strings, the return type is a string. It basically describes the service. So if we go back to the slides for a second, these are the SOAP attributes you saw previously. I'll go back to some of those other slides we just had a look at. I'm looking for I'll actually not worry about looking at it on the slides. I'll go back to the actual code. So the SDL, which describes the service, uses SOAP and XML. So the nice thing about SOAP is that it's a human readable standard and that it's very easy to detect errors. Because being text-based, there's a lot of redundancy. It's very easy to find out if there's any problem with a SOAP request. Also, because it's text-based and it goes through HTTP via the XML, you can use it like it's machine and platform independent. So what actually happens if someone wants to use this web service? So let's actually try and use the web service, which basically just outputs a hello string. So we'll create a new project. We'll make it just a console application. I don't want to make anything too complex. So Win32 project, we'll call it console. We'll add it to the current solution. It's a simple console application, empty project. So let's just add a source file to that so we can actually, so we'll call it console. And so this is just going to be a very basic example of how you can use a web service. So we use the add web reference dialog to connect to web services. We type in the location of the disco file, which basically just contains a link. In terms of ATL server, it'll just contain a link to that SDL description we saw a moment ago. So if we go, I believe that was the name of the disco file. Let's just check. demoservice.disco. So if I tell it to go to that, it'll flash around for a while. And it should connect to the web service. Now, as it has. So basically, you can see it was just a link to the SDL, which it's cut down for us. Basically, this dialog here just runs a command line utility called Sproxy. Sproxy connects to the service, gets the SDL, and we'll use the SDL to generate a C++ header file, which contains everything. So apparently you're going to see Sproxy in action. The add web service dialog has been working on and off as well. So let's go to the web service. Let's run, let's hope. So unfortunately, let me try and find why I can't. Oh, actually, I might be able to run Sproxy on this machine here. Okay, so all's well. I'll go to the shared directory. And all I'm doing is just running the Sproxy, and I give it, as you can see if I run it, just give it the input file, the SDL. So you can actually give it the web location. So in this case, it's the localhost posters demo service service.dll handler equals gen. I can never remember the complex format we used to name our SDL. Gen demo service service SDL. Gen demo service service SDL. And we'll call the output file proxy.h. So hopefully Sproxy will go get the SDL. It says it's successfully created proxy.h. If I copy proxy, I'll copy it to the local machine. And we'll just have a look at the proxy file. So I'll actually add it to the project, add existing item. Put it in the demo service directory, proxy.h. So here's the proxy that's been generated for us. And basically, you can see it's created a C demo service service class. And that class, through a lot of complex code, is going to the web service and downloading and talking to the web service for us. So all we need to do, you can see there's a lot of code that's been created in there. In our console application, we will include our proxy service. And now let's create a type of C demo service service. And I'll just build that to make sure I haven't got any typing errors, which I apparently do. Oh, okay, so this is a small error which we can easily fix. Basically, you need Win32 defined to be the latest version. I hope. Oh, thanks. That was silly. Okay, so hopefully this time it will build. And we can just have a quick look at the web service. And please feel free to ask any questions about anything as we go along.
Seems like the host name of the target server is in the proxy header file.
Yes, sorry, the question was if the host name of the target server is in the proxy header file.
Is there an easy way to externalize that so if you were to change the location of the server, like migrating from one environment to the other, you wouldn't have to recompile your code?
So the question is if you can easily change it so that when a service changes, you don't have to recompile your code if it moves location. There's not a very easy way to do it. I mean, we have been looking at setting up some sort of configuration file where you can set up information like that. There is a problem. I mean, this is native C++. So everything we have is compiled code. So we don't have the advantage of the .NET frameworks of being able to do a lot of stuff like that on the fly. They get to do a lot more features like that. But we are looking at having some sort of configuration file which you can optionally use where you can set things like the server location, which obviously is a reasonable thing to change over time. So let's just call so we have cdemo service. So I have the code here, if you give me a moment. So let's just call into our function. This is what I want to do to print up the information. So hello world is the name of the function. That's what I was looking for. Oh, so IntelliSense has finally decided to work as well. So we basically, we can give it any input. This will probably give me errors. I haven't used beasters in a while now, so. What the So hopefully this time it will compile. Apparently not. Uppercase. Oh yeah, I should probably use ccom beaster actually. So maybe this time it will compile. Oh, otherwise, yeah, I'm going to have to. Just give me a second. Yeah. So if it doesn't work this time, I'll just skip over it. I didn't write the beaster service. I don't like beasters at all. Oh, well, actually, this time we're okay. So it would be nice though if I actually outputted the service. Let's see. That's not going to go. Just give me a second. With a capital, it'll do it. Okay, so we will actually see it running thanks to some helpful people around who know much more about beasters than I do. So let's just have a look at the demo service. Console. And if I run the console application, finally, it'll return null. Okay. So actually, that should work. I've obviously just made some error. But because we're running out of time, I will try and... So attributes I was talking about earlier, they basically work with the compiler. The compiler just injects code whenever it sees an attribute. Yeah. So the question is, can you create your own attributes? With VS7, you will not be able to create your own attributes, but it is something definitely that they've been looking at, and hopefully with VS8, you will be able to create your own attributes at that time. What I do want to get to is the final part of the talk to let Tony do the conclusion, if he's wired up.
Okay, thanks, Pranish. Ladies and gentlemen, this was Pranish's first public presentation, first demo. It's always tough, especially considering that our that the builds that Pranish were using was not one of the public builds that we've actually released, which, for those of you that got the PDC build, it's available on products. That's build 8905. And we will be releasing a beta of Visual Studio.NET, including Visual C++, probably towards the end of October, early November timeframe. And a lot of that stuff should be progressed to the point of being quite stable, using that term loosely. So how do we actually look to see the .NET and native interop going along? Well, one of the great things about the use of web services is because they are platform independent, they're language independent, they're object model independent, we can very, very easily create, through the use of web services, applications that utilize these native components. So you could imagine having a highly processor-dependent mathematical calculation, for example, and you can use a distributed system utilizing ATL server and web services to go and hand off that calculation to another computer and have that actually work and execute. You can also have it going the other way around. Inside our native code, now while we talked a lot about ATL server today, in fact specifically ATL server, we've added the ability inside Visual C++ to consume web services inside MFC, inside ATL, and in your native code. So you'll be able to very, very easily leverage these web services from the .NET platform into the actual C++ code itself. You can also take advantage, if you were at the keynote this morning, you would have seen the end of my demo showing a C# application but calling existing COM components, existing APIs, the DirectX stuff. So we have a great level of support for your existing code and for native code interoperation. And one of the things that we haven't really talked much about are the managed extensions for C++. They give you a great way to actually take native code and start to progress that at a class level into the .NET platform. Now, one of the cool things about that class level is this is the first time ever you will be able to take C++ classes at the class name implementation level and actually share that with VB, with Eiffel, with Ada, with all these other languages without needing to go and create these COM wrappers on things. So all of that really does allow you the flexibility in choosing how you're going to implement your back-end systems, and then the ability of us to actually use, consume, produce both HTML, adaptive UI, and XML really does allow you the choice of what you want as the client and what you would like as the actual server. So just very, very quickly, some of the other special features that are in ATL Server. We have the ability to do thread pooling as a native service. We have mail support, very simple SMTP, mail processing. We have support for security, localization, locale and code page, and an HTTP request processor. Now, the architecture is factored fairly well. So if you don't like the way we do SMTP support, you can take that out, replace it, and actually implement your own SMTP support. You can actually also do the same thing with the caching support in ATL Server as well. And so a lot of times, if you're building a specialist system, you'll know more about the requirements of caching on your particular application than our generic cache could be. So you can, again, target that specifically. All of this support is provided in the ATL Server libraries. The source is there, you can see it, you can see how we implement it, and you can go and replace, consume, or use that. So where do you go to get more information? Well, you can go and get the PDC drop. It's on products. So, and I think that's ITDDS hyphen something for international people. But it's on products. If you go to products beta, you'll find it there. It is rather substantial, so if you're thinking of downloading it and taking it, you will take a little bit of time. The ATL Server homepage is on the intranet at HTTP Manta. You can go to the VC homepage, VCQA0. If you've actually got a Redmond domain account, you can also go from VCQA0 to our term servers that we utilize for testing of this stuff and be able to log onto the terminal servers and see the latest builds. 89, 82, I believe, is reasonable. Was that what you were running there?
Yeah, that was it.
Okay, I believe it's not reasonable. Questions? You can either email myself directly, it's tgoodhew, obviously at Microsoft.com, or alternatively, the ATL team itself is at ATL SVR. And you can go and find docs, slides, presentations like this, white papers and so on the actual Manta server. So if you go there, you should be able to get stuff. If you can't find things you need for customers, or you need to get some positioning or stuff like that, please feel free to send me an email. We'll get that stuff to you. I think ATL Server is one of the most exciting parts of our native support inside the Visual C++ product in the VC.NET release. So that brings us to our end of our presentation. If you have any questions, more than happy to take them now. Otherwise, thank you very much for attending. Yeah.